Okay, so we're getting into properties of kites. Okay, so a kite is a quadrilateral. They are not parallelograms. Okay, so here's a kite. When I have a kite, they have exactly two pairs of congruent consecutive sides. So these two are going to be congruent. The other two are going to be congruent. This gives me a kite. Okay, so we got a couple of properties about these, and both of them have to deal with angles. The first one is going to be about the kite's diagonals. So let's take a look at that one. Okay, so the first property says that if I have a kite, right? So let's call this A, B, C, D, and I draw in the diagonals. And let's say that the diagonals meet at point M. So this is a kite, so that's going to be congruent to this, and this is going to be congruent to this. What we want to say is that the one diagonal, BD, is in fact perpendicular to the other diagonal, AC. So the diagonals of a kite are perpendicular. Now, in your notes, there's a formal proof of this. Again, I'm going to walk through this, but not in a formal way. All right, so let's see how we can go after proving that this is in fact true. Okay, so AB and AD are congruent because it's a kite. BC and DC are also congruent because it's a kite. If I look at this segment, AC, it is part of two different triangles, the one on the top and the one on the bottom, and it is congruent to itself by the reflexive property, right? So AC is congruent to itself. So this tells me that triangle ABC has to be congruent to triangle ADC. Why is that? That's because of the SSS theorem. Now we always prove triangles congruent in order to get, what are they called? Corresponding parts congruent. So this tells me that the angle BCM has to be congruent to, sorry, not triangle, but angle DCM, right? This is because they are corresponding parts. One is in the top triangle, one's in the bottom. So I have this congruent to this. I also know that segment MC is congruent to itself. So that's this red segment here. So if you look, that's going to give me side angle side, right? So we now can say that triangle BMC has to be congruent to triangle DMC by side angle side, which means that angle BMC has to be congruent to angle DMC by CPCTC. Okay, so if I think about this, right, these two angles, BMC and DMC, also form a line, which means that if I add them, they have to add up to 180 because they form a line. They're a linear pair. Okay, so if they're both the same size and they add to 180, this means that they're each 90, which means that's a 90-degree angle. If that's a 90-degree angle, that means that these two things are perpendicular. So there's kind of an informal readout of the proof that you'll find in your notes that says that the diagonals of a kite have to be perpendicular. So it's like a rhombus that way, but without having to require four congruent sides. All right, so let's look at the second thing that we know. Okay, so in this one, we're going to have the kite again. And we're going to call this A, B, C, D again, and we're going to draw in the two diagonals. And we know it's a kite, so this is congruent to this. This is congruent to this, right? So what do we want to show? It says that exactly one pair of opposite angles are congruent. Okay. So the pair that's going to be congruent is we want to say that angle ABC has to be congruent to ADC. Now this is fairly easy to prove because earlier we did this trick by showing that AC is congruent to itself, right? Which means that the top and the bottom triangles, triangle ABC has to be congruent to triangle ADC by side, 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 which means ultimately that angle ABC has to be congruent to ADC by CPCTC. So now let's get that correct. CPCTC. There we go. Which is what we're trying to prove up here. So only one pair of opposite angles are going to be congruent, and it happens to be that pair. All right, so kites are quadrilaterals that are not parallelograms. Their diagonals are perpendicular, and they have one pair of congruent opposite angles. That's it.